So good morning, good afternoon, and good evening, guys, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick information if you all can see my screen and hear me loud and clear as well? Great, thank you for confirmation, everyone. So before we get started, let me quickly introduce our Edureka Masterclass community with you all. So this community of masterclasses was started back in 2019, and since then we have been closing into more than 32,000 members so far. And in these master classes, we have been in these master classes, we have been conducting more than almost 100 webinars in a given month on different topics, including blockchain, IoT, artificial intelligence, machine learning, big data, and multiple front-end and back-end development technologies. And the best part about these webinars are they are absolutely free of cost, so there are no charges involved here. And to be a part of this group, we can simply refer to this link here, which says join this group, and we will be notified with the entire schedule that we have planned for the month. So now we are going to start our discussion on the IPL data analysis using Python, how exactly we can get started. So here we are going to discuss on how exactly the data analysis works. So first thing first, we are going to discuss on what exactly is data visualization. Then we are going to learn on why is data visualization important. Then we are going to learn the benefits of data visualization. And then we are going to talk about the data visualization tools. And then we have the visualizations available in Python as well. So that is what we are going to discuss as a part of our discussion in today's session, one by one. All right, so first of all, we are going to talk about what exactly is data visualization. So first of all, if we talk about data itself, then data visualization is basically, we can say it's like a field. It's like a field that deals with the graphical representation of data. And without proper visualization, we will not be able to make sense out of any data that we are going to work on. And that's why we have to make sure that if we do convert every data format into a good visualization part so that we can make sense out of the data that you want to work on. All right, as a part of data visualization techniques. And why it is important. So here we are going to understand on why exactly it is important. So see, data simply, we may have the access to 1,000 petabytes of data, but again, without visualizing it, for example, just by looking at the tabular format, we may think, okay, the data is almost similar, but in reality, it may be completely different, right? So we have to make sure that whatever data set we are working on, that we should be having a clear-cut insight, because we don't want to allow the company or the decision makers to have incorrect data set, because again, if they make the decision based on wrong information given by us, then that can have drastic results, right? Which we definitely do not want. So that is why we can simply make sure that we are going to use this concepts of data visualizations in order to ensure that we are going to get a better insight, and then on that insight we can simply allow the users, without the company stakeholders, to make better decisions. So there are multiple benefits of data visualization. So first thing is it simply allows us to define correlations and relationship, how one table, for example, if we are talking about database and how one table is related with the other, that is what we define here. What are the common trends and what is the frequency with which the data is currently expanding, and what kind of predictions we can make, how we can examine the market, and what are the risk and reward involved in this entire analysis. That is what we can easily visualize by using this setup. Now, there are multiple benefits of data that we have. For example, if we talk about defining the correlationships in data set, so here we can say, now if we talk about correlation itself, then correlation is basically a measure or a degree of relationship between two different variables. Now, as one set of values increases, the other set tends to decrease, and this is called as a positive correlation. Now, as one set of values increase, the other set tends to decrease, and then it is called as a negative correlation. So we can simply refer to this diagram as well. For example, here we can see if one value increases, then the other one may increase or decrease. So we can say that these two data sets are either positively correlated or they are negatively correlated. And we also have high positive correlation, we have low positive correlation, we have high negative correlation, we have high positive correlation depending upon the requirement. For example, as we can see here, if we increase this pointer, for example, we can see how if we suppose increase the data pointer by 1 point, for example, here we may increase it by just 1 point, and again increasing in one, also if it also we can say results in increasing of this pointer to one as well, that means they are perfectly correlated, right? If we increase this by suppose let's say by 2, and then the value here increases by suppose let's say 1.5, then they are not going to be perfectly correlated, but again they are highly correlated. If we increase again to 3, and suppose if there is no change here, that means they are not correlated at all. I suppose if it increases to 3, and again if it goes down by suppose 1, then they are negatively correlated, and so on. That's how it works. So here we can simply define the pointers and how we can make use of it. Next, we had to analyze trends over time. So trend is what a hip or popular at a certain point of time. So while a trend usually refers to a certain style in a fashion or entertainment, there could be a trend towards warmer temperatures as well. So what exactly the trend has been, and based on the past trend, what kind of predictions we can make for the future, that is what we can infer by using the same data analysis itself. And then frequency. So frequency analysis is a numerical method which provides a clear representation of the global dynamics of many multi-dimensional systems as well. So basically, it provides a clear representation of the global dynamics of many, or I can say of many companies and again many data sets, which is particularly useful for a system of 3 degrees of freedom or more. Now, basically here we can allow this to work on data set, which where we are going to study some kind of density maps as well. We are going to study the frequency with which one rapid increase is going to be increased. For example, we may use it to analyze the rate at which the COVID cases they are going to rise in one specific region, or what is going to be the density of that rise, how they are going to be increased. So these all different pointers can be analyzed as a part of this data science analysis that we are going to do. And then it comes down to examining the market. So a market overview is basically a brief, we can say, synopsis of a commercial or industrial market. Now, its aim is to provide current snapshot of a market in order to better understand its key features. A simple example is the company needs to understand which category of products are going to be more in demand in next 6 months, right? A brand may be really popular right now, but again, it may not be popular at all after 6 months, right? So what exactly those brands are going to be? If suppose, let's say one after 6 months, we can say there's going to be a huge demand for a specific set of products. So what exactly that is going to be, so that we can get a good profit out of it. So again, these things can be easily visualized by using the data science domain. And that's why it is used for increasing the accuracy of the predictions. That means again, there's nothing of a guarantee here, but again, here we simply make predictions with the most accuracy. So in case there are some kind of, again, we can have the predictions made with the least chance of getting ourselves wrong. And that is what we achieve by using data visualization, or we can say data science techniques. All right, so next is we have the risk and reward as well. So basically, in terms of risk or reward, so again, here we have to make sure the risk reward ratio marks the prospective reward an investor can earn for every dollar they risk on an investment. Now, many investors use risk to reward ratio to compare the expected returns of an investment with the amount of risk they must undertake to earn these returns. So do you think stock market, now the big players, they invest in stock markets like randomly just on their own hypothesis, or they have a well-defined, you can say well-defined analysis done, then only they invest the money? Everyone? Now, small players, they may invest just on a pure luck, just randomly. But again, the big players, they always make sure that they first of all study the entire stocks. They use their own algorithms to understand what exactly the current situation of a stock is, and how much likely it is going to grow or decrease in value in the near future. And that's how they simply try to minimize the entire risk. Obviously, risk is going to be there, but again, using this informed decision, they are going to simply decrease the likelihood of any losses. All right. That is what we define as a part of order of risk and reward again. And that's why the entire stock market portfolio, they are done on base of risk and rewards itself. That's how it works. Now, there are multiple data visualization tools available. Like we have Power BI, we have tools such as Click, we have the Neo4j, we have Matplotlib by Python, we have Plotly, Seaborn, GraphTool, Bokeh, Altair, Zoho Analytics, we have IBM, Tableau platform, TensorBoard. Yeah, and so there are multiple platforms available out there which help us in visualizing data set. Now, almost every tool that we can see here, they all are open source. That means open source as in, now Power BI, Tableau, they are not open source, but again, they have a free community edition available that we can make use of, right? Whereas the Bokeh, Altair, Matplotlib, Plotly, they all are different libraries available under Python that we can make use of. They all are different libraries that we can make use of under Python. And then that exactly is what we are even going to learn as we proceed further step by step. All right, so let's talk about some data visualization on top of Python itself so that we can have a better understanding of how exactly that can be done. All right, so since the entire goal of this training is to work on data visualization of IPL, so here we are going to get the IPL data sets. So we are going to get the data from Kaggle itself. So this is the data set available in Kaggle itself. Now, first of all, if you want to get the notebook itself, we can simply go ahead and click on download. So first of all, we have simply log in to Kaggle. Where we can use our own Google account or any other account, and then we can get the access. So it's a free data set. So we can simply click on download, and then we would be able to download this data and work accordingly. That's how it is going to be. So as you can see here, we have these two data sets currently available with us. So here we have for deliveries and then we have for matches. And these two data sets are the one that we are going to work on as we proceed further step by step. All right. So now here we are going to solve multiple questions. That means how many matches we have got in the data set, how many seasons we have got in data sets, which team had won by maximum runs, which team had won by maximum wickets, what was the closest margin. So these all things we are going to process one by one as we proceed further. So what we can do here is we can simply now either if you want we can work in a local notebook, or we can also make use of Colab as well. So again, Colab is also offered by Google, just like we have Jupyter Notebook. We can make use of Colab to get started. And again, we can start our discussion on the IPL analysis by simply naming the file as well. So for example, here we have IPL analysis. Now here we can start defining the code. So first of all, we have to now before even we can work on this one, we have to make sure that we do upload the data in a Google Drive, because again, at the end, whenever we are going to work on Colab, we need to have data available in Google Drive, right? And that is what we have to work with. All right. So here we have made a folder by the name of IPL data, and now to make use of this, and again, we also have to upload the data that we have downloaded here into this drive. So what we can do is we have to simply drop these in the same drive so that we can make use of it. So both of them are currently available. And here, now if we are going to make use of Colab, so Colab is useful when we don't have any kind, we don't have a high-end configuration system, so that we can avoid getting any kind of, we can say, low performances. All right. So if we are making use of Colab, then we have to make sure that we do upload the data set that we have downloaded in a folder under our Google Drive account, and then we now to map the data to this notebook, we have to click on the file section available in the left sidebar, and here we have to link it. So here we can simply click on connect to Google Drive, and again, so this is simply going to insert a code that will allow us to add a Google Drive code here. Just a moment. All right, so now once we get connected to our drive here, so we can see here we have multiple drives available. So now here we are going to work on the IPL data set, right? So here we have this IPL data that we are going to work with. And now once we have mounted here, so that means now we can make use of this file directly. So now first of all, we are going to import numpy. So here we can import numpy, as NP. So this is what we are going to do for the numerical analysis. All right. And then we are going to define panda. So here we can define import pandas as PD. So this is what we are going to do for working on the data processing component for CSV. And then we are going to simply read a CSV as a part of a discussion. But again, first of all, let's import all the libraries. So here we are also going to import matplotlib and .pyplot. And here we are going to import it as a part of PLT. And then we are going to import Seaborn. We are going to import Seaborn as SNS. So these all are different libraries that we are going to import. And to work on these, first of all, we can simply type in the die command. And again, if we want to insert the library, that means we want to execute this, we can simply click on play. Play means we are simply going to run these commands here one by one. All right. And then, so to make our plots look nicer, we are simply going to use a theme. So we can make a use of a theme here as SNS. So here we type in as SNS dot set style. So we can simply make use of a theme here. For example, here we have a theme available for suppose dark grid. So here we have dark grid. Again, it's an inbuilt theme available under Seaborn, and here we can use plot.rc parameters. And here we are going to define the here we are simply going to define the figure size. So first of all, we can define the figure dot fig size, and the figure size we can keep it to suppose let's say 14.8 for plotting the graph. And then we have to simply read the input as well. So here we are simply going to execute each and every statement here. So as you can see, a style has been set. So we can simply keep on running all the commands here. Again, we can add one more. So here we are going to simply read the file that we have saved in our Google Drive. So here we can find file path. Now, if we are using your local drive here, for example, if you have data stored in your D drive under data, and then you have the matches data, right? So you can define that location of your local file. Now, since we have uploaded data back in a Google Drive, right? So here we have to make sure that we do include the data set here. So for that, we already have mounted that. So again, here we have IPL data, and under IPL data, we are simply going to include the matches detail here, right? So again, this is the entire detail that we are going to match. So here we are going to specify the file path as the one that we have defined. So this is currently available under my drive, and then under IPL data and matches or CSV. All right. And then we can simply create the file as suppose matches. Now here we are defining the file path, and for reading the file here, so here we are simply going to define our data frame as file matches, and then for reading data we are going to define pd.read underscore csv. This is an inbuilt function available under pandas, and we are going to read from the given file path plus matches.csv that we have defined. So in case we want to read all the content, then we can now in under the file path we can keep it to all, and then we can specifically define we want to save data as matches or CSV under this component as a part of definition that we are going to add. And to convert this to a single component, we can simply define pd.read underscore CSV, and then we can define the location of the file path depending upon the requirement. So here we can do this in one way or the other. Okay, it depends upon the requirement. So we can run this in this single context as well. We can do that. All right, so we can do anything, and then we are going to get the basic information out of the data set. And for that, to simply print the shape here, so we can simply define matches dot, or we define this as matches dot shape. So here, basically, if we run matches or shape, then again the shape of this data set is also going to be printed. It means, as you can see, there are 636 rows and 18 columns available in this current data set. And then we can simply see different here. We want to visualize, okay, which team won by the maximum numbers here, right? So we can simply visualize everything. For example, let's say we want to simply see, okay, how many unique seasons we have got in terms of the entire data set. So here again we can click on expand or new code, And here we can define, suppose, from matches, we can define, suppose, the seasons. Now, from matches, we are going to define the unique count of seasons. That means how many unique counts, how many unique seasons are currently available in the same data set that we have currently imported. So all the season details they are going to be simply defined, and if you want to return it as a part of the output, we can define as and when required. So we have multiple seasons available here, and again, they are going to be done as an array. As you can see here, here we have seasons data for 2008, 9, 10, 11, 12, 13, 14, 15, 16, and 17 as well. So again, they all have been written as an array. And now we want to see, okay, which team had won by maximum runs. So again, for that, we can again enter a code. So now here we are simply going to define which team won maximum by maximum runs. So for that, we are simply going to run the command as matches dot alloc, and here we are going to make use of same matches data frame matches. We can remove this now, and under matches here we can define this one for. Now within matches we can define, we want to focus on win by runs. So here we have win underscore by runs. So again, these are all the data already available with us in the CSV file that we have imported, right? And that is what we are working on it. So here we define matches.ilog and dot matches. So basically here we are going to make use of, so here we have ID max. So ID max is simply going to return the ID of the maximum value, which in turn is going to be fed into the ilog, which is going to take the index value, and then it is going to return the row itself, right? So here we are simply going to know, okay, which team won by the maximum runs, and as a part of the entire component, again, this is going to be defined one by one. And now if you want to visualize this, we can also visualize this as well. We can erase this up. And suppose here we can make use of Seaborn library, and here we can simply define count plot. And by count plot, we want to define, okay, on x-axis we are going to plot season, and then on the data we are going to make use of matches. For data, we are going to simply make use of matches data frame. So we have the matches. So here we have the matches data set we are going to work with. So this is going to simply show us a graph of the number of matches played in all seasons. We can see most number of matches were played, almost more than 70 in 2011, 12, and 13 as a part of complete visualization part. That's how we can start with the IPL analysis itself. Thank you so much for joining, guys, and have a great day ahead. Take care. Bye-bye.